Welcome to Lesson 7 in Unit 18, The Power of Water. In this lesson, students will work to answer the question, how can electricity be produced in a river without a dam? Students go through the engineering cycle to design, build, test, and revise a device to produce electricity in moving water. Students figure out that energy can be produced in water without a dam using a device that spins underwater. Scientists and engineers work together in teams to design such technology, and it impacts our everyday lives. Students make connections to the storyline by understanding that dams aren't the only way to produce electricity in water, and if the dam is removed, the river can still be used as a natural resource for energy. There are several opportunities for math and ELA cross-curricular connections throughout the lesson. You can look for specific standard connections in the Unit 18 Teacher Guide. This lesson will take approximately 4 days to complete. For the Engage portion, you'll ask students questions about reasons to keep and remove the dam, as well as how energy may be generated without a dam. You'll show a video about sustainable energy from rivers. Then show a video clip of a river device working. You'll ask students to share what they notice and wonder about the device that the engineers and the Igiugig community created to produce electricity, and whether or not they think a device like this could replace the Glen Canyon Dam. You'll revisit the driving question board and highlight questions connected to the learning goals of this lesson by calling attention to questions about how electricity might be produced without the dam. For the Explore portion, students will build a river device. Prior to class, review the river device engineering activity tutorial and prepare the materials. Notice that the multimeter must be placed at the 10 amp setting as shown in the tutorial that is linked in the teacher guide. Pause this video to review the list of needed materials and the photo showing items you can find in your kit. You'll project the engineering design cycle. There is also an Engineering Design Cycle student journal page for students to reference. You'll divide students into engineering teams of 3 to 4 and provide them with the Engineer a River Device student journal page. As a class, review steps 1 through 4. You'll then show students all of the materials they have available to them. You'll ask students how they think they could use the materials to design a device that produces electricity and how they will know if the energy is present in their design. They can then brainstorm in their groups how they could use the given materials to build a water turbine that can harness as much electricity as possible within the given constraints. You'll then bring the class back together and have students discuss how they think the materials could be used to build a water turbine that meets the criteria. You'll show the students the river turbine base tester and the multimeter and explain how they will design a piece for the front of the base using only the materials in the kit. You can use the river device engineering activity tutorial slides to show them an example model. Based on their brainstorming, students should create an initial model of a water turbine. For the Explain portion, engineering teams will begin testing their designs. You'll show them the setup and explain how each group will attach their device to the base, which is attached to the electrical wires and a multimeter. Explain how the multimeter measures how much electricity the device is producing. You'll then display the river device's class data table and explain that they will add the class data into the table. After all of the groups have tested, you'll review the class data and have each group hold up their design as you review their multimeter readings. You'll ask students how the devices produced electricity and about the similarities between the designs that did or didn't produce much electricity. As students respond, you can use provided prompts to encourage more student talk. For the Elaborate portion, in their engineering teams, you'll have students review the outcome and observations from the testing of their devices. You'll have students draw and label a model of their redesign idea and answer the questions in Step 7 of the Engineer a River Device student journal page. You'll then have a brief class discussion on how science is a human endeavor as it relates to this lesson. You'll tell students that most scientists and engineers around the world work in teams and ask what examples of science and engineering teamwork they notice in this lesson. You'll then let students know that the work scientists and engineers do together affects our everyday lives in many ways, and ask them how the science we worked on in this lesson could affect everyday life. In the Evaluate portion, you'll remind students of the phenomenon. The Glen Canyon Dam on the Colorado River is controversial because it impacts people, animals, and the environment in positive and negative ways. You'll ask students what information they have learned that would help them further explain this phenomenon. You'll have students continue using the Public Service Announcement Planner student journal page that they started in Lesson 3. You'll have them fill out the reasons to remove the dam section and encourage them to use evidence from the student journal pages from Lessons 4 through 7, as well as the summary charts developed by the class. By the end of this lesson, students will have applied scientific ideas of energy transfer to design, test, and revise a device to produce electricity by transferring energy between objects. In Lesson 8, students will create a public service announcement on the Glen Canyon Dam controversy. For more information about this unit, visit myscipartners.com.